when you picture an industrial robot, you probably have this uh, highly specific, almost intimidating image in your head, right?
Oh, definitely. Usually it's this massive, rigid mechanical arm.
Right. Surrounded by those heavy yellow safety cages on like a noisy automotive assembly line or something.
Yeah, moving with that terrifying, relentless speed.
Sparks flying, metal clashing. The whole design philosophy of that machine is just about raw power and, relentless efficiency. Human beings are basically meant to stay far, far away from it.
Exactly. It's a completely isolated zone.
Well, welcome to today's Custom Deep Dive, brought to you by Triple Automation, where we are looking at exactly what happens when that dynamic completely inverts.
And it is a massive inversion.
It really is. Today, we're exploring the moment these machines graduate from the heavy, isolated factory floor and step into one of the most sensitive, unpredictable, and zero margin for error environments on the planet. I'm talking about healthcare.
And the transition we're witnessing here is profound. I mean, we are looking at a fundamental shift in how we define a human-centered workspace.
Historically, like you said, we kept our most advanced physical machines quarantined behind fences. But taking a robot out of a cage and putting it next to a hospital bed or a sterile lab bench.
It's not just a software update.
No, it's not merely a technological upgrade at all. It requires a complete architectural rethink of what a machine is actually supposed to value.
Right.
The barrier between industrial machinery and caregiving tools is dissolving, and that carries massive implications for how medical facilities operate under the surface.
So let's get into the specifics, because the catalyst for this particular shift is a major engineering milestone that was recently achieved by JAKA Robotics.
Yeah, they're new collaborative robots.
Exactly. Their JAKA S series, specifically the S5, the S7, and the S12 models, along with their MiniCab control cabinet. They recently received the IEC 60601 medical safety certification.
Which is no small feat.
Not at all. Now, for anyone listening who isn't spending their weekends analyzing international regulatory frameworks, IEC 60601 is the global benchmark. It is the absolute gold standard for healthcare equipment. It really is. And getting that stamp of approval is notoriously brutal because the testing criteria are just entirely unforgiving.
Yeah, you can't just scrape by.
What's fascinating here is what this certification actually guarantees, because the rigor of it makes total sense when you look at the economics of failure.
What do you mean by that?
Well, think about a traditional manufacturing plant. If a robot fails there, you lose time, you lose a batch of product, and you lose money, right?
Right, it's an operational headache, but nobody's in physical danger usually.
Exactly. But in healthcare, there is zero room for error. A failure cascades into a life safety issue instantly.
Wow, yeah.
So this certification proves that the equipment must not only perform its intended task perfectly, but it must actively protect patients and medical professionals during an absolute worst-case scenario.
Even if something inside the robot itself goes wrong.
Exactly. If a component breaks, or the software glitches, or a sensor misreads, the system has to maintain safety. It has to fail safely.
Okay, let's unpack this concept of failing safely, because I think understanding the mechanics of that is really crucial for you, the listener. Kind of reminds me of the engineering in modern transportation.
How so?
Well, imagine you're driving a highly engineered car down the highway, right? And suddenly the engine completely dies. Just a catastrophic internal failure.
Oh, right. Terrifying scenario.
Yeah. But instead of the steering locking up and the brakes failing, the car's internal fail-safes take over. The power steering remains active via a backup battery, and the car predictably, glides to a safe, soft stop on the shoulder of the road. Is that the kind of dynamic we're talking about with the S-Series?
It's a great analogy for the outcome, but the mechanical reality is actually the exact opposite.
Wait, really? The opposite?
Yeah. Because a car uses forward momentum to coast to a gradual stop. If a JAKA robot loses power while, say, holding a tray of volatile lab samples, or while operating right next to a nurse, coasting is a disaster.
Oh, because coasting means unpredictable movement.
Precisely. It can't drift. It has to instantly lock its joints to freeze in place, basically dumping its kinetic energy without dropping the load or drifting into a human's physical space.
Ooh, wow, that makes so much sense.
Yeah, the S-Series and the MiniCab control cabinet are designed so that if an anomaly is detected, like a sudden power surge or a mechanical slip, the system enters this secure, rigid state. It ensures that its immediate physical footprint poses absolutely zero threat.
Coasting with a tray of biohazards is literally how you get a contamination crisis.
Exactly. The machine has to prioritize rigidity over momentum.
Which means we're essentially taking the robot's primary directive from do the task and upgrading it to do no harm. We are engineering the Hippocratic Oath into the actual physics of the machine.
That's a great way to put it.
Okay, so now that we know these JKS series robots are officially certified, safe enough for the hospital, let's look at what they are actually doing there. Because they aren't like rolling to the ER to perform open heart surgery, right?
No, not at all. They are stepping into environments like hospitals, laboratories, and pharmaceutical production spaces.
Right.
And their roles are highly specific. They are targeting the operational bottlenecks that drain human endurance.
Like moving supplies and prep work.
Exactly. In a hospital, the behind-the-scenes logistical burden is just staggering. You have the constant movement of heavy medical supplies, transporting sterilized equipment trays between floors, handling routine processes.
All the grueling prep work that has to happen before a clinical procedure even begins.
Yes. And in laboratories, the bottleneck is sample handling. Think about the high-throughput testing required in modern diagnostics.
Oh, I can only imagine.
A technician might need to move hundreds of individual vials from a centrifuge to an analyzer, doing repetitive testing steps, pipetting tiny amounts of fluid for hours on end.
Just picture a typical chaotic hospital day, Put yourself in the shoes of a lab tech or a nurse for a second. The sheer cognitive load is unbelievable.
It really is.
If a robot can quietly handle that heavy lifting, or the repetitive sample sorting, doesn't that fundamentally change the daily endurance test of a healthcare worker?
It completely changes it. In traditional industrial settings, the goal is pure efficiency. Make it faster, make it cheaper.
Yeah.
But in these new environments, the goal shifts to care, trust, and reliability. These robots aren't here to replace medical staff. They are here to support them.
Let's talk about the pharma side of things, too, because that's a whole different level of stress. We tend to think of human beings as these ultimate precision instruments, but we're actually terrible at sterile consistency.
Oh, we are walking contamination risks.
Yeah. A human operator breathes, they shed skin cells, they radiate heat. No matter how many layers of protective gowns and masks a pharmaceutical worker wears in a clean room, they are still the biggest variable in that controlled production process.
Absolutely. And plus, humans fatigue. A lab tech might be brilliant, but after 4 hours of moving tiny test tubes...
Your hand might shake slightly.
Right. Your attention drifts. It's a documented operational hazard. The S5 or S7 robot, by contrast, improves consistency and reduces human error. It executes the 1,000th movement with the exact same millimeter precision as the first movement.
It doesn't breathe, it doesn't shed particulates.
And it doesn't suffer from cognitive fatigue. It maintains the absolute integrity of a controlled environment effortlessly.
But, safety on paper and millimeter precision are one thing. A piece of paper detailing an IEC 60601 certification doesn't stop a nurse from flinching when a metal arm swings past their face in a crowded lab.
No, it doesn't.
To successfully integrate into these high-stakes, stressful environments, the robot can't just be safe. It has to actually feel safe and natural to work around. And the JKS series are specifically categorized as collaborative robots.
Or cobots, yeah.
Right. So how does a machine actually communicate safety to the human nervous system?
It comes down to the psychology of motion. The S series features smooth, controlled movements that feel predictable to humans.
Predictable is a key word there.
Exactly. Industrial robots of the past were completely blind and indifferent to their surroundings. But collaborative robots are unintrusive. They integrate naturally into existing environments.
Because, as humans, our brains are biologically hardwired to track erratic motion as a threat. Like, if something moves aggressively, our nervous system spikes with adrenaline.
Well, I feel hunted.
Yes. But if a robotic arm moves in smooth, predictable arcs, our brain just filters it out as background activity. We relax around it.
And a major factor in that unintrusive design is the MiniCab control cabinet. It works behind the scenes to ensure secure, reliable operation.
I'm so glad you brought up the MiniCab control cabinet.
Mm-hmm.
Because for a hospital administrator listening, the physical footprint of this stuff is a huge deal. Usually industrial robotics requires massive server racks of processing equipment.
Huge power demands, heavy cabling, usually have to tear down walls to accommodate them.
And a hospital simply cannot afford to shut down a wing for a month to retrofit an industrial control center.
Right, which is why the MiniCab is so important. It condenses all that power.
It makes the technology actually deployable.
If we connect this to the bigger picture, the direct human impact here is profound. By integrating naturally, there is less physical strain on the medical staff and smoother workflows for the facilities.
Hmm.
And that reduction in physical strain directly translates to more time for medical staff to focus on what truly matters: the patients.
Right.
It creates this halo effect where the patient feels they are in an environment that is safer, more reliable, and hyper-focused on care.
Here's where it gets really interesting, though. It's almost ironic.
What is?
Bringing a highly advanced, complex piece of automation into a hospital room actually makes the patient's experience more human.
Oh, absolutely.
Because the human doctor or nurse finally has the physical and mental bandwidth to actually look the patient in the eye. They aren't rushing out the door to track down a tray of sterilized tools.
The machine handles the mechanical, giving the human the freedom to handle the emotional.
Exactly. So, with the S-Series proving right now that robots belong in these human-centered spaces,
Hmm.
where does the industry go from here? Technology like this doesn't just stagnate.
Oh, no. JK is already preparing for the next generation of intelligent platforms.
What does that look like?
Well, there is continued investment in artificial intelligence and research. The ultimate goal is smarter, more adaptable systems that bring lasting value to the people inside these industries.
Adaptable is huge in a hospital.
Right, because the clinical floor is not a static environment. Emergencies happen, layouts change.
Yeah, a hallway might suddenly be swarmed by a rapid response team. The robot needs to know more than just stop.
Exactly. This raises an important question, really. We are witnessing a total redefinition of where technology belongs. It's the permanent escape of robotics from the factory floor into the places we live and heal.
So what does this all mean for you, the listener? Whether you're a patient, a healthcare worker, or just someone observing tech trends, the barrier between industrial machine and helpful assistant has officially been erased.
It's completely gone.
Let's briefly recap the journey of today's deep dive. We started with that rigorous IEC 60601 medical safety certification of the JAKA series, the S5, S7, and S12 in the MiniCab.
The gold standard.
Right, proving they can fail safely. Then we look at the practical hospital applications, moving from assembly lines to labs and clean rooms to assist with repetitive processes.
And we covered how their collaborative, smooth design reduces physical strain on staff.
Exactly. And finally, we looked at the AI-driven future of smarter, more adaptable care.
It's an incredible trajectory.
It really is. Now, as we wrap up, I want to leave you with a final lingering question to ponder on your own.
Okay, let's hear it.
If collaborative robots eventually take over all the mechanical, repetitive, and physical tasks of healthcare, will the future of medicine require us to select and train our healthcare professionals entirely based on their empathy and bedside manner, rather than their technical stamina?
Wow, that is a fascinating thought.
Sounded you on, right? Well, thank you so much for joining us on this custom deep dive. We always love exploring these topics with you. Take care. We'll catch you next time.